So you will see these are the small spots which we want to highlight. By dilation, these spots have grown. The size have grown. So very small white spot having shape nearly like a structuring element will be dilated. Okay. I told you that here I am using only gray examples I have taken with grayscale. Grayscale is black and white. I am taking 1 and 0, but you may take weighted also. Then in case of color, different RGB template will be different. I am only discussing the basics. It's not that this is only the morphology. This is the basic. I told you that once the basics are clear, then depending upon your requirement, you can develop another template where some weightage is also given. You can have, because that also I told you that this is the domain knowledge. The morphology depends upon size, shape, intensity. If the doctor says that the size is like a diamond, size is like a 7 by 7 pixel, and the central portion of the tissue is darker, these other tissues nearby are lighter, my structuring element, the central portion will have value which will be near 0, side pixels will have values which may be 100, 150, 120, so my structuring element is developed. And then I will apply, I will show to the doctor, is there any improvement? If he says no, then again I will do it next second iteration. So this will be an iterative process. So until the end user is satisfied, until you are satisfied with the understanding of the doctor, what exactly he wants, the domain knowledge has been transferred to you, it will not be possible. It is like this, if you have a scooter, I give this example many times, when somebody has a scooter, he goes to a technician, he says that my scooter is giving lot of noise, the technician will start the scooter and immediately he will tell the bearing has to be changed. Because he has the knowledge that if the sound is like this, then this sound is because of defective bearing. So now if we do same in our image processing or signal processing, in signal processing, that is the sound. If the sound is very shrill, it is a high frequency sound. If the sound is very low frequency like tabla etc., it will be a low frequency sound. If we record that sound, do the frequency domain analysis, if we find that the normal scooter sound is around 200 Hertz. Now when the technician told it is having bearing problem, there was 1 kilohertz sound which was dominating. So I got this domain knowledge. If in the scooter, if I record the sound and if I find 1000 Hertz signal is present, then I will say automatically this scooter is having problem with the bearing. So this domain knowledge is a must that I have to discuss with the doctor. I have to go through the medical books. I will see that this tissue which I want to identify, what is its shape, what is its size, what are the various intensity or shading pattern, only then I will design my structuring element. So you will find that in the literature, people publish papers, they will say I have used morphological filter, dilation or this, and he has the pattern, but he will not give the shape of the structuring element. So rest the knowledge is available in the books, no problem. But this knowledge is not available, which is with him only. So even if Philips people, they give the circuit diagram of all their amplifier, etc. But the details, the filter they are using, what is the cutoff frequency, what is the range of the frequency, that they never give. So even if you copy that circuit and develop your own amplifier, etc., the performance cannot match. Whatever days together, mandates they have put in research, that knowledge they are keeping with them. So similarly in this case, structuring element, I told in the very beginning, it is the shape, it is the size, it is the intensity, it is the color, it is the pattern. So if I work only on the basis of shape, I forget about the intensity, I will do some enhancement, but it will not be ultimate. If I use size and shape, it will be still better. If I use size, shape and intensity, it will be still better. So I can go on improving my this image by adding more and more function. It may be difficult also if you take all the parameters in the very first row. So better will be you develop slowly so that you also gain knowledge and experience, and you also get confidence. Freeze, this is the size. Freeze, this is the shape. Then go for intensity, etc. Okay? Any other point? So this is what you are asking for. We can give various weightage also. Okay? So in dilation you will see the original image, dilated image, the black area will reduce, white area will increase. The inside the circle, this black area has reduced. So as a you can say signal processing person, I must know that this is the white area. Wherever white area was there, it has increased. So erosion is the reverse of this. I will not go into the detail. I understand that what was done with dilation, erosion is reverse of that. We can use the same structuring element for dilation as well as erosion. Okay. So erosion will try to see like this. Blue is the original and green becomes the last. Here there is some problem. Probably arrow should be round. Okay. So structuring element this. Now in this case the size has reduced. By erosion the black area will increase. By erosion image will become more darker. By dilation the image will become more brighter. See, when we show to the doctor, you want to show him by enhancement certain areas you have identified and you have highlighted. But along with that, if you change the intensity, if you change the brightness, maybe that intensity change brighter or darker. He may not, in the first impression, he may not look into what you have done, what you have improved. He may say that, अरे image बहुत बेकार हो गया, बहुत bright हो गया, बहुत dark हो गया, ये तो black सा हो गया, पहला image बढ़िया था. So that means that is also important. We must keep in mind कि ये जो dark हुआ है या bright हुआ है, this is because of the mathematics. It's not that something has been done in the image which is not advisable. So if we know that we can increase or decrease the brightness, you must have done number of many of you must have used number of softwares which are available. कि आपने कोई फोटो ली, उस फोटो का Photoshop or many other software, you can increase the brightness, you can decrease the brightness, you can increase the contrast, it is so simple. You can develop your own 10-line program. Any image you can increase brightness, contrast, etc. And in that case you will have in mind how this brightness is being increased. So here also similar type of techniques can be developed by you to reduce or increase the brightness. Okay. Some of the information which are smaller in size and the shape is not like a structuring element, I want to remove that. So any noise which may be confused, with which I may be confused, I want to remove that. So I want to remove area where this type of information is not there, but it is pretending to be like a structuring element. I want to thicken that area which looks like a structuring element. So we will see later on next. Blue is my original image. Blue is the area in the image. This area, if I want to erode by using a disc-like structure, so I will erode that, I will reduce the size of that. If my size of the blue is very small, then by this structuring element this will be removed. Now the size is blue, after erosion it has become green, middle one. So I have reduced the size. If my structuring element is like just rubbing off. If the size is very small, by this structuring element the whole area will be clean. So that means there I do not have any information. This I want to remove. I do not want to have any confusion with respect to this area. So erosion is shrinking operation. One is dilation, another one is shrinking. Structuring element mask is transferred through the image. This we have already discussed. So you will see that this is my original image. So in case of erosion, the black area will be increased, white area will be reduced. So smaller white patches will be removed. So you will see in the eroded image, smaller white patches are removed. Now we will see, these are the two mathematics. Our aim is to highlight small black, small white patches similar to structuring element. Those we want to highlight, we want to show to the doctor. So far what we have done, elements which were smaller, we dilated. Elements which were smaller, but they were white, we just made them black, we just removed them. Now we will see that how these two techniques we will use. So the technique, say in erosion you will see, this is the eroded image. I am interested in these three dots. Rest I have removed. These are the three dots. Now just take an example. This is say PCB. I just want to erode these small patches. This is a line which is a thin line. This is a thick line. If I use a disc-like structure of radius 5, my thin lines will be removed. Central thick line will become thin. If I use this size radius 5 to 10, all the connecting lines will be removed. So this I will show like a PCB person. If it is shown to me, I will say yes, there was no connection. If it was coming in the image, this should not be there. So I will use a structuring element. If 5 is good enough, I will say these lines, they are because of bad image. They are because when you take a photograph, some lines, some scratches may appear. So I will say this is a bad image. I have removed those patches. Now if I say that even this is not required, then I will get this. If I want even this is not required, I use a disc which is higher than 10. So I will get only the central portion. So again you will see here the structuring element size and shape. This shape was such that it was taking care of thin lines. The shape and size both become important. Now another one is, now we will use these two mathematical tools to our benefit. We have understood what is meant by dilation, we have understood what is meant by erosion. Now we will see what are the applications. One is opening of an image. These are the names given and accepted very commonly by the people working in this area. So these are standard terminology, may not have very close meaning with the function which they or the effect they have with respect to opening and closing. Say opening of an image I by structuring element, it is defined that erosion followed by dilation. Erosion followed by dilation. See, in erosion and dilation, the nature of the tissue structure in the original image has changed. In one case we have eroded, in another case we have dilated. So original shape has changed. I want that the smallest the lower side black and white spots having shape near to my structuring element should be highlighted. Now what I have changed the nature of those structures. So first I will do opening. Opening means first I will erode, then eroded image I will dilate. So by erosion I will remove unwanted things. By dilation, eroded image will be dilated, same structuring element, so original shape will be there. So my aim will be the elements which were very small I have removed and original is there. So this is image enhancement. This is image enhancement. Image filtering, in frequency domain we remove frequencies which are unwanted. By morphology we remove structures which are unwanted. So simply by using this we have removed some of the area, structures, shapes which were not of our interest. Now here losing any information we should be very careful. So structuring element size shape becomes more important. So light detail smaller than structuring element is completely removed. Any light bright spot less than structuring element will be removed. Okay. So anyway, this you can read. So you will see that these are the spots. By erosion, the smaller dots we have removed. So bigger dots, 3 dots are there. By dilation, I get these 3 bigger dots. So smaller shapes I have removed. My original image is highlighted with, it has only information where I have interest, without changing the nature and shape of that information. Is it okay? So opening, I have already told you this is an open image. So rest of the dots I have removed. Now reverse to this opening, again you will see this is open image. This is eroded. In erosion, the black area inside this has increased. Outside also it has increased. So by dilation, it is the same. So it should be clear that by opening we have removed certain area which is of this nature. Okay.
So where is medical imaging this is used?
Medical image में मान लीजिए मुझे tissue, I have to identify a tissue which is having a shape like a diamond. So I will find out if the diamond say shape is 5 by 5. So and I want less than that is noise. I have to first find out in my image by this modality in X-ray or image processing, MRI or ultrasound, this type of noise can be there. In ultrasound, scattering noise is there. Now scattering noise may interfere with my tissue, abnormal tissues. So I want to remove scattering noise. I will study the nature of that scattering noise. So that scattering noise I can remove by using this method.
Medical applications.
Medical.
Ultrasound
is scattering. Ultrasound.
These are done with such a procedure, so there is the possibility noise could be there.
Yes, actually ultrasound when they take, it is the physics, it is the basic principle that scattering will be there. When they focus ultrasound, there are small particles inside the body. Ultrasound gives an echo whenever there is a change in the media. Whenever there is a change in media, ultrasound, say from the boundary of the liver, echo will be there. Inside, echo will be there. Gallbladder, boundary, echo will be there. If there are stones, different stones will give different echoes. That is why they are able to identify stones present. Now, echoes are also there from tiny biological particles inside the body. That tiny biological particles, they do scattering of the ultrasound. That scattered ultrasound is also taken as an image in the image. So scattering is a very, you can say, very common problem in ultrasound. It is there in all ultrasound. They try to remove that, but scattering you can only reduce, but you cannot remove. The doctors, they identify tissues even under that. they have understood what is the nature of this particular scattering and what is the shape of the tissue. So our aim is again same, if some of these noise which are giving some confusing results having shape similar to my structuring element, I would like to remove that. Okay. So in this case also the same, this particular portion I have removed, this particular portion I have removed like this. So opening is erosion followed by dilation. First we apply erosion, then we do dilation. Now closing of an image is reverse of that. Dilation followed by erosion. First I dilate, then I erode. First I dilate, then I erode. Let us see what happens. When I dilate, this is my circling element. When I dilate, I am increasing the white area. So with the close of opening, I could reduce the, I was increasing the black area. With closing, I am increasing the white area. By increasing the white area, this black dot is gone. So by increasing the white area, this black dot is gone. By dilation, these black dots are highlighted. Or by erosion, these black dots are highlighted. So in this case, earlier I have removed white dots. Now I have removed black dots, which are smaller than structuring element. Now I get image in which small white dots are not there. I get processed image in which small black dots are not there. Now it becomes very simple. From the original image, if I subtract this, I will be left with either black dots or white dots. I will be left with either black dots or white dots. If these black dots and white dots are of my interest, and these black and white dots doctors are not able to see visually, I am able to highlight. Now whatever I said earlier, say these may be noise, etc. Now you see this has information which the doctors, being of size which are smaller than a particular structuring element, which by naked eye, because of by their experience they are not able to identify, they are being missed. Those black and white dots I can highlight by original image minus opening, original image minus closing. So only those white dot and black dots will be left. So next you will see closing. Any small bright spot, if it is there in the image, having nature nearly structuring element like will be highlighted. So this is top hat, another one is bottom hat, it is reverse of that. Earlier bright spots, now we have dark spots. These bright and dark is for the black and white images, for grey images it can be different intensities, for colored images it can be different. So more you go for more deep in knowledge, you will find that better and better methods you can develop. So my aim here was only to give awareness, but it's a very interesting field, image processing. If you go ahead, if you try to develop your concept, then you will start enjoying. You take one image, try to process. Take different structuring elements, see what is there in that. Or you make your own image by having different structuring elements. Now out of those structuring elements, if you want that this shape I want to remove, select a structuring element, see in an image that area you have identified and you have removed. It is like this, you have a mixture of grains, wheat, different type of grains are there. You are telling your mate that you just take out these grains. So you have given her the idea, knowledge that the wheat grain is a wheat color is this, size is this, shape is this. So immediately, even if she is illiterate, she will pick up those grains having that shape, size and color. So same thing we do. We have been given an image. We just want to find out in this image, is there any structuring element which is having this shape, which is having this structure, size, which is having this color, which is having this pattern? The doctor, they want to see that. And we as a signal processing person, using some mathematical tool, we would like to operate on that image so that same information is extracted. That is the simplest what we want to do it. So bottom hat, now contrast enhancement will be, now I told you that by using this, by extracting small dots, by extracting black dots, there may be some change in intensity. Now what I do, I take an original image and I superimpose on the original image these whites and black dots. So the area which is white, if it is not 255, if it is say 240, 230, that 230 will become 255. Only that area where these spots are there, either it will be made more bright or it will be made more dark. So those patches which earlier was looking like near brightest patches, near black, say slightly grayish, they will become more black and they will become more grey. And rest of the image, in the whole image, only those spots will be touched. So rest of the image, I minus top hat minus bottom plus top hat minus bottom hat, only this will be these spots, area around in the image, around these spots will be changed. Rest of the image is not touched at all. So that means doctor may not find any change in the image. He can see that the whole image is as it is, but only the spots you have identified, and that spots have become more bright or more dark. So that is what we wanted to attain. So by morphological filtering, this is possible. The model which can be developed, say this is the overall model, erosion, dilation, top hat, then dilation, erosion, bottom hat, this is the image, this becomes my output. So I have tried 2-3 my PhD students, they tried on mammograph etc., ultrasound, different structuring element after having interaction with the medical professionals. So we could develop some structuring element which was useful. So with this I close my discussion and hope all of you must have enjoyed.